I'm going to talk about the order of zeros and poles, and I'll just give you a couple of quick examples. So to figure out, and these will be calculus-y because they'll give you kind of the basic idea, and they're just a little bit easier to get the concept. So the order of a zero, let's suppose we have f of x, and I'm just going to factor this. X minus 1, x minus 2 to the 17th, x minus 3 to the 101. Right? So if you could somehow, and then maybe let's multiply by e to the x, like that. Right? So if you calculate the zeros, this is going to have exactly 3 zeros. And every function in the complex plane that has a zero, you can write it as z minus 1 if there's a 0 one times something else that is holomorphic near 1, if the function was already holomorphic. So the zero is essentially the biggest exponent you can pull out. So this is 1. So f has a 0 of order 1 at x equals 1, because that's the biggest power I can pull out. Right? I can't factor out an x minus 1 out of any of those. And it has a factor 17 at x equals 2, and a power in a order of 101 at x equals 3. So that's what we mean by the order of a zero. The order of a pole is very similar. So here's, let's call this g of x. I'm going to write this as, I'm going to give it a whole bunch of poles. In fact, let's just make this 1 over f. 101 times, how about e to the x equals 1 over f of x. Well, the question is, this has, clearly I can divide by 0 if I have poles at 1, 2, and 3. And those are the only poles that I'd have, right? Right? If I plug in any other number, that's going to be non-zero, that's going to be non-zero, that's going to be non-zero, and that's going to be non-zero. So I'm going to be good. So here's the basic idea. Notice how much do I have to multiply to cancel this out of the denominator? Well, notice that x minus 1 times g of x is equal to 1 over x minus 2 to the 17th, x minus 3 to the 101, e to the x. Oh, that's perfectly good. So at 1, this does not have a pole. So this has the poles of order 1. Similarly, if I do x minus 2 to the 17th times g of x, I'm going to get 1 over x minus 1 times x minus 3 to the 101 e to the x. So if I plug in 2 into this, there's no problem. So the order here is 17. And by the same reasoning, the order at 3 is going to be 101. So that's the basic idea of how you figure out the orders of zeros and poles, is basically what can you multiply by. And notice there could be some trickery going on. Let me just maybe give you one example of that. If you have maybe this times, I don't know, how about just e to the x again? If this is your function, you might be tempted to say that this has a 0 of order 1 at x equals 1, but you'd be wrong, because look, this factors as well. This is equal to actually x minus 1 cubed times e to the x. So this actually has order 3. It's a 0 of order 3 at x equals 1. So you need to make sure you factored out everything. That's the idea behind orders of zeros and poles. Thank you.